Welcome to our channel. Today, we're diving into the fascinating world of solar cell physics. Get ready to uncover some mind-blowing facts about how these incredible devices work. You see, solar cells are like tiny power plants that convert sunlight directly into electricity. It's pretty amazing. They're made of special materials called semiconductors that have this incredible ability to capture the energy from photons, those tiny packets of light energy from the sun, and turn it into electricity. It's like magic, but it's science, and that's what makes it so cool. So buckle up because we're about to embark on an electrifying journey to explore the science behind solar cells and how they are illuminating our world. Have you ever wondered how solar cells, those sleek panels you see on rooftops, actually transform sunlight into usable electricity? Well, it all boils down to a remarkable phenomenon known as the photovoltaic effect. It's a big word, but stick with me. You see, when light, in the form of photons, strikes certain materials, it can knock electrons loose from their atoms. These freed electrons are now free to flow, creating an electric current. This is the basic principle behind how solar cells generate electricity. The photovoltaic effect is like a game of billiards, where photons act as the cue ball, transferring their energy to electrons and setting them in motion. It's a fascinating process that underpins the entire field of solar energy. Now, not all materials are created equal when it comes to the photovoltaic effect. Solar cells are made from special materials called semiconductors, which have unique electrical properties that make them ideal for capturing and converting solar energy. Semiconductors, like silicon, the most common material used in solar cells, have this amazing ability to conduct electricity under certain conditions. When light strikes a semiconductor, it excites the electrons, giving them enough energy to jump to a higher energy level and become available to conduct electricity. These excited electrons are then harnessed by the solar cell's structure, creating an electric current that can power our homes and devices. It's like semiconductors are the conductors of an orchestra, directing the flow of electrons to create a symphony of electricity. Chapter 3. The p-n junction, where the magic happens. Now let's talk about the secret sauce of a solar cell, the p-n junction. This junction is formed by joining two different types of semiconductors, a p-type semiconductor which has an excess of holes, positive charges, and an n-type semiconductor which has an excess of electrons, negative charges. When these two types of semiconductors are brought together, something amazing happens. The electrons from the n-type region diffuse into the p-type region, while the holes from the p-type region diffuse into the n-type region. This movement of charge carriers creates an electric field across the junction, like an invisible barrier that keeps things interesting. This electric field at the p-n junction is what gives solar cells their ability to generate electricity. It acts like a one-way street, forcing the excited electrons to flow in a specific direction, creating a direct current, DC, that can be used to power our world. Chapter 4. Light to Electricity, the grand finale. Alright, now let's put it all together and see how light energy is transformed into electrical energy in a solar cell. Picture this. A beam of sunlight, packed with photons, shines onto a solar cell. When these photons hit the solar cell's surface, they penetrate the semiconductor material and reach the p-n junction. Remember that game of billiards we talked about? Well, here's where it gets exciting. The photons, acting like tiny cue balls, transfer their energy to the electrons in the semiconductor. These energized electrons are then swept across the p-n junction by the electric field, creating a flow of electric current. And voila! We have successfully converted light energy into electrical energy. It's like a tiny power plant, right there on your rooftop, silently harnessing the sun's energy. Chapter 5. The future is bright advancements in solar technology. The field of solar technology is constantly evolving, with scientists and engineers working tirelessly to improve the efficiency and affordability of solar cells. From new materials like perovskites, which promise to revolutionize solar cell efficiency, to innovative designs like flexible solar panels that can be integrated into clothing and buildings, the possibilities are endless. One exciting area of research is in developing solar cells that can capture a wider range of wavelengths of sunlight, increasing their energy conversion efficiency. Other advancements include transparent solar cells that can be integrated into windows and even solar paints that can turn any surface into a power generator. The future of solar technology is incredibly bright, with the potential to transform the way we power our world. as we continue to unlock the secrets of solar cells. We can look forward to a cleaner, more sustainable future powered by the sun. Outro powering a brighter future. Thanks for watching. If you enjoyed learning about the science behind solar cells, don't forget to like, subscribe, and hit the bell icon for more exciting science content. We've explored the fascinating world of semiconductors, the magic of the p-n junction, and the incredible journey of light transforming into electricity. Remember, solar cells are more than just shiny panels on rooftops. They represent a cleaner, more sustainable future for all of us. Keep those questions coming, keep exploring, and keep that spark of curiosity alive. See you next time.